Hi, this is Greg McLaren with Lightship Security, and today I'd like to show you how to conduct full NDcPP TLS server-side testing in under a minute using our man-in-the-middle tests. Our automation tool is designed to minimize the amount of configuration needed while ensuring consistent results and immediate repeatability. We use a device profile which mimics the selections and assignments in the protection profile and ultimately the security target. It is a simple human-readable text file. Let's get started. To construct the profile, simply use your favorite text editor. I'm going to use VI. The syntax of the device profile is simple and hierarchical. Once you have one defined, you can use it as a model for other profiles to accelerate your construction. If you have more than one TLS server listening on the target, simply create one profile per server instance. The first thing is to build the skeleton of the profile. We give the profile a name and an optional description as well as a host and port to direct the network traffic. Then we have to provide a protection profile definition. In this case, we're going to target the NDcPP version 1.0, so I'll write those in here. Every protection profile has SFRs, and some of those SFRs will affect how the tests are conducted. So we will need to fill in the SFR selections and assignments that make sense for this device profile. For the NDcPP version 1.0, that means we need a set of supported TLS versions and a set of optional cipher suites. The device profile already has the intelligence to add any mandatory cipher suites before it is run. Because of the way the NDcPP version 1.0 is arranged, the FCS, TLSS, EXT SFRs are common for the server authentication and the mutual authentication cases. So we'll use an asterisk to show commonality. When supporting mutual authentication, the same SFRs can be used in the configuration with appropriate augments for the specific mutual authentication case. Let me add a small set of optional cipher suites for the prospective target we'll test after we finish building the profile. Again, note that I'm omitting the mandatory cipher suite because the tool will automatically add it later during runtime. While there are other user-definable sections for FCS TLSS EXT 1.2, the selection actually follows from FCS TLSS EXT 1.1 when we define the set of supported TLS versions. So we can leave that SFR blank, and the tool will automatically set the right values at runtime. For FCS TLSS EXT 1.3, the user-definable sections are related to the claimed cipher suites. Each of the key establishment parameters must be at least defined, but they can be empty if no cipher suites are claimed against them. So we'll start by adding the outline structure of those completions. Because the mandatory TLS cipher suite requires RSA key exchange, there is a mandatory 2048-bit RSA key value that will automatically be added by the tool during runtime. We don't need to add it again. These are only for optional items. If your target supports ECDHE key establishment, then you will need to provide the set of available named curves. These curves must be the RFC supplied names. Our target has one ECDHE cipher suite defined, so we'll add the supported curve, SecP256R1 in this case. Our target does not support any ephemeral Diffie-Hellman key establishment cipher suites, so we'll leave this last section empty. However, if we had some defined, we would simply add the sizes in this defined list. And there we go. Our entire configuration is just 30 lines long. It can be used for the same target over and over, or it can be used as an example to rapidly build out another device profile. Now the device profile must be dropped into the profiles directory in order to make it available and active. So let's do that now. After this, we can list the available profiles by showing the help screen for the automation tool front end. If necessary, we can test the consistency and syntax of the device profile. Let's give it a quick check. Before running the automation tool, ensure your target is accessible. In my case, I'm going to set up a quick and dirty OpenSSL S server instance to simulate my target of evaluation. Note that the set of cipher suites in my simulated toad differs from those provided in my device profile I just authored. This will result in failures during testing. Finally, before we run, I need to ensure that I can capture the network packets. I have already started an instance of Wireshark and set it to sniff the local host on port 443. Now we have a tow, we have a profile, and we can run the automation tool. If you look at the help screen, you can see that there is a way to conform with a specific scheme or the ITC. If no such scheme is given, all tests will run by default. In the background, the tool is injecting and rearranging the necessary TLS messages to adhere to the strict and complex NDcPP man-in-the-middle test cases. As expected, there are some failures occurring due to mismatched cipher suite or protocol version expectations. After completion, the execution log and other artifacts are dumped to the output folder, or folder of your choice. Wireshark has captured all of the incoming and outgoing packets from the test tool, and we can now conduct an analysis. While the tool indicates that the various tests have passed or failed, you don't have to, or necessarily want to, take our word for it. The proof is in the output log as to what steps were conducted, and more importantly, in the network traces. Let's open up the log file to see a typical execution run. Here you can see FCS TLSS EXT 1.1 Test 1, which cycles through the mandatory and defined optional cipher suites. The first thing in the test that you see is Start Packet Marker. Each test will send an ICMP echo packet with a payload having the name of the test case in it. In this case, you can always use the ICMP packets as a landmark in the Wireshark trace to determine where TLS handshakes start and stop for specific test cases. You can see this in the Wireshark dump. And here's the finish marker for FCS TLSS EXT 1.1 Test 1 with the start marker for Test 2. Analysis of the results, both successes and failures, using the captured packet traces can be performed quickly and easily with our companion user guide. It lays out the various packet structures, the landmarks to look for, where the changes ought to be found, and why the results are expected to be correct. So thanks for watching. Contact us at info@lightshipsec.com to get more information on this and our other exciting automation tools making structured protection profile testing simple and efficient.